Hey guys, welcome to the channel. My name is Jae Wilson. I'm a freelance consultant through my company, Onyx Reporting. Today, we're going to talk about confusion matrices. Now, I see you. I see you reaching to change the video. Don't do it. Don't worry. I'm not teaching you stats today. I'm not a statistician. I'm also not really a data scientist. So we're going to just play to our strengths. Today, I'm going to talk to you guys about the questions you need to be asking as you're employing data scientists. So my target audience for this video is kind of like major domos and also business consultants, because our job is to let the data scientists build models, but we have to figure out how to use them effectively in our organization. So let's talk about that. Confusion matrices. Well, first a little history, guys. This is super cool. Apparently, confusion matrices were developed back in World War II, I guess, when radar was first being developed. And the problem they were having with radar at the time is they were trying to figure out, okay, what are the perfect settings for my radar machine so that I accurately classify bombers as bombers as opposed to a flock of seagulls. So imagine, right? I've got my radar set up the way it's set up, and I have a false positive. I identify, I think that I have a squadron of bombers. So I scramble the jets. I get them gassed. I get them up in the air, right? I tell all the city people, hey, go to your bunkers because we're getting bombed. And then turn to find out it's just a flock of seagulls. Think about the resource cost and the drain on the pilots, right? They get combat fatigue. We've got to worry about paying for gas. We've got to worry about just the morale of the city. People can't just constantly be living in fear. That's terrible. When I say it out loud, it actually reminds me of how terrible war is. Jesus. Okay, turn side of the coin. If I turn the knobs too much to the left, right, to minimize my false positives, what happens if I get a false negative? What happens if I mislabel a squadron of airplanes as seagulls? Then my city gets bombed. And that's where this whole confusion matrix concept comes from. It's how do I choose the model that minimizes the thing that I don't want, right? My false positives versus my false negatives. Okay, that's the background. In real life, I kind of wanted to tell you guys about my first consulting engagement in Domo. I was working with a customer and they're like, Jay, we want you to identify customers who are going to churn, customers who are going to leave us. And I'm like, that sounds like a cool project. So I do my data science wizardry, right? And then I come back with this confusion matrix, and I'm like, look at my beautiful confusion matrix. Look at this. I have identified 23 out of the 25 people who are going to churn. That's pretty good, right? Well, here's the problem. I was talking to the guy in charge of customer success, and he was rolling out this big customer retention program that they were very excited about. And he's like, Jay, look, this is good, but look at this number here. You have almost 50% of the 43 churners, almost 50% of them were never at risk of churning. I'm running people through a customer retention program that costs me budget. And half of the times they weren't even at risk. Can you get that number down? I'm like, all right, fine. So I go home and I work on a different model. I tune the dial a little bit to the left, and then I come up with this model. And here, I've minimized my false positives. And I instead have a model that allows false negatives to run rampant. And I'm showing these two models to my executive sponsors on this project. And my customer success guy, he's super stoked because he's like, this is great. Look at this. I am not burning a lot of budget on people that are not at risk at churning, so I'm doing my job. But the revenue guy, he wasn't impressed at all. He's like, Jay, look at all these false negatives. You told me 20 people were not at risk at churning and they left us. But and here's the thing, I don't think you understand my business. The cost of customer retention is pennies on the dollar compared to the cost of acquiring a new customer. Think about it. We send them some swag, a happy email, like, a Christmas card, and we keep them. That costs us like what? $17. Cost of acquiring a new customer, that's jets. That's whining and dining. That's time. Cost of customer acquisition cost. That's the part that kills us. And I said, look, guys, y'all need to sit down and figure out how this is all going to work because I'm just a data scientist. I don't know your business. That is not at all the language that I use. But hopefully you get my point, right? There's only so much I can do for you. The other half of it you have to figure out on your own. Or I can help you build a model. And that's what we're going to do here. So they said the customer retention program, $17 to send people swag and a gift card. Cost of acquiring a new customer, $250. Now here's the cool part. They told me their customer retention program had a 33% effectiveness rate. Just by sending somebody a gift card, they feel some love, they stay with you. 33% effectiveness rate. And I said, okay, fine. We have these pieces of information. Let's see how that plays out in our model. So, in model number 1, are false positives. We have a lot of false positives. That means we send 43 people through our customer retention program. 43 times 17 is 731. That's a big number, right? And that's why my customer retention guy, he wasn't thrilled about it. But this is cool. Because we identified 23 people at risk of churning, we were able to save 23 times 0.3, because that's my success rate. We were able to save 17 people from churning. And so 7 times 250, my customer acquisition cost, that's $1,750 that we don't have to give out because we retained that customer. Now, my model was good, but it's not perfect. I had 2 false positives. I had 2 mislabeled customers. I thought they were going to be loyal, and they churned on me. And so that costs me $500 for a net of 519. Not terrible, right? Let's look at the other model. Now, remember, in the other model, I just swapped. In one, I'm penalizing false positives. The other one, I'm penalizing false negatives. This is, again, just turning the knobs and dials for bombers and seagulls. So, my customer retention program. I run 7 people through my customer retention program. My customer retention guy is happy because his budget looks good. He's only spending $119 as opposed to $731. Because we run 5 churners through my customer retention program, we keep 2 of them. 2 times 250 is 500. But because this model does not penalize false negatives, because it allows me to mislabel a lot of churners, I actually end up spending $5,000 in new customer acquisition costs for a net of minus $4,619. So clearly, given the cost of new customer acquisition, Model 1 is better than Model 2. Now, I can't know this for your business, right? That's the whole reason why we're having this video. I don't know all of the ins and outs of how your business works, but this is the kind of stuff business analysts and major domos, these are the things you need to be working with your data scientists on. Because your data scientists, what they're going to say is they're going to say, hey, we've built 10 models. Now, which one do you want me to prefer? Do you want me to favor the ones that minimize false negatives or the ones that minimize false positives? Do you want me to favor recall versus precision? That's the language of a data scientist. But for we mere mortals, that means nothing. And so building out how does my business work and what do I do with the information once I have it, These numbers here, this cost equation, that's how I figure out what the better model is. But here's an interesting thought. What if your company works totally differently? What if cost of acquiring customers is very low? Imagine you're famous. Like, you walk down the street, people know your business. And so, like, you're like, to attract a new customer, what do I gotta do? I just have to do like a little bit of Facebook, a little bit of Instagram. All of a sudden, bam-o, I've got new customers. Easy. Now, what if you have a book of customers that have been with you for 4, 5, 6 years? They've become accustomed to being treated with kid gloves. They've become accustomed to fancy dinners. They've become accustomed to being flown around the world to like special events and whatnot. And the cost of retaining your customers goes up. Now, just by swapping these two numbers, all of a sudden, Model 1, terrible model. I'm out $10,000. Model 2, I remember that number being different. Model 2, not so bad. Because the cost of, I'm minimizing the cost of retaining customers, and I recognize that the cost of replacing customers, not really worried about it. So that's the deal on confusion matrices. At the end of the day, it's not important that you really understand the ins and outs of a confusion matrix. What you do, however, need to do is you need to have an idea of how you decide what a good model looks like and versus a bad model. And if you're doing classification, are you a bomber or a seagull? If you're doing a classification, build a cost equation that will help you understand and choose which model makes the most sense, because it's not always intuitive. My name's Jae Wilson. I'm a freelance consultant through my company, Onyx Reporting. I hope you like this video. I'll catch you guys later.